Welcome back, people. Today we are solving Leetcode number 944, delete columns to make sorted. As you can see, this is an easy problem. I think Leetcode is starting us off easy, and towards the end of the year, we'll probably be getting really difficult DP problems and tries and graphs. So let's enjoy this while it lasts, right? So this problem says that we have an array n of strings, and all these strings have the same length. Okay, that makes our job very easy. And we can arrange it in such a way that it's a grid, so ABC, BCE, and CAE, right? And they said we want to delete columns that are not sorted lexicographically. That means that when we are reading this from ABC, okay, this is sorted, so this is fine. But we have BCA, and technically A should come before C. So this is off and this is wrong. And then we have CEE, so this is fine. So we have to delete this second column, rather this column 1, because then we count from 0. So delete column 1, and that's it actually. And we just have to return the number of columns that we delete. So we're not required to return the values in the column that we delete. We just have to return the number of columns that we delete. So they went on to give us more examples like CBA, DAF, and GHI, in which case we have CDG here, and this is fine. BAH, this is wrong, so we'll delete this one. And then AFI is fine. So in the end, for this one, we just delete one column. And then for A and B as well, we have the column is sorted, so we don't delete anyone. So in this case, we return just 0, right? And so on and so forth. And then I wanted us to actually pay attention to the constraints, because they told us that the n is the same thing as the string dot length here, which means that the length of each of the strings is always going to be the same as the length of everything in the array. So for instance, we have the length of the string being 3, and that means that the length of the string is 3. That means that the length of the array as well will be 3. Hope that makes sense. And also this would help as well. It says it consists of only lowercase English letters. This makes our job even more easier. So let's go on and let's talk about the solution, and let's actually get to solving it. Okay, so I think the biggest problem here was figuring out how to know which letter comes before another letter. So at first I was thinking, okay, you know what I'll do? I'll just make a list, I'll just create an object and assign values from 0 to 26 to that's from A, and then depending on if the letter before it has like a value higher or lower, then I would know if it's if it's coming before the word or after the word. So I was going to do that, but then I realized that JavaScript already has a way of doing this, and I don't really necessarily need to make that list. I've solved the problem before where I used that particular solution, so I just remembered that, and I was like, oh yeah, that could work, and yeah, it did. So basically my solution was just to figure out a way to, so first of all, of course, we're going to be traversing through the array, but instead of traversing through the array from A to B, then to C, then from B to C to E, we'll be doing from A down here to B next, to C next, and then from B here to C, then A, right? And from C to E, and then E, right? And that was all we had to do. And then if we are traversing here, and for instance, A in this method I'm going to show you is going to be 0, because that's the first letter of the alphabet, right? And it's 0, and we save that the value that we got is 0, and then we move down and we see B is 1. B is greater than the first one that we saw before, so that means that it's still lexicographically how do you pronounce that word, lexicographically correct. So we still move on with that, right? And then you see the next word, that's C, and C is straight. So that's fine. That tells us that, okay, when we get to this point, we can reset our counter or whatever it is that we're using to keep track, and we can reset it and say, okay, now we start again from B this time. Now when we get to B and we start from B, now it starts from 1, and then the next one is C, which is straight. Now we see an A, and A is going to always be what? 0. Now that we've gotten a 0, we know that, oh, if we have a 0, it means that this value is it's not next, it shouldn't be in that, it's not sequential that way, right? that means that this letter was supposed to come first before this other letter that we just saw. So that means we need to delete this entire column. So we have to keep a count of the columns that we're deleting, of course, and then at the end we just return that column. And then I thought about something else, right? What if, for instance, we have like a long list of columns to go through, right? But in between, there was a way for us to actually like know that okay, this is not going to go on. Like for instance, in this example where we have C and then we have D and we have G, for instance, and then we have B and then we have A. Now we don't even need to check the last one. We are supposed to already know at this point that we're going to delete this column, so there's no need to check the next one, right? And yeah, so that's something I have to keep in mind as well. Now, for this solution, because we're not going to be creating any extra space, thank God, it's going to be an O of 1 solution. And because in the worst case, we're going to have to go through every single letter, right? Because just assume that all the wrong letters or all the columns that you need to delete are in the last, that's in the last row, right? So in the worst case, we have to go through every single letter, every single string in that array, right? So our time complexity will be like O of m times n in that case. And yeah, so let's actually stop talking and get to solving. And let's first declare our variables. Let's declare the deleted column variable, which are going to start off as 0, because if you remember from this example that we have here, if we don't have any columns deleted, we're supposed to return 0. And then let's also keep track of the previous character value, right? So this previous character value tells us, okay, this was the value of the character that you had before. Let's compare it to the value of the character that you have now. If it's greater, then that's fine. We just replace this character count value, right? But if it's less, we know that okay, no, this is supposed to have, this letter is supposed to have come earlier, so we're going to be deleting this column and we reset the character count, right? So let's actually start it off as 0. And for our return statement, we're going to be returning the deleted column. Right. So to go through this loop, we're going to be having like a for loop that's basically going to be less than let's go with the first item in that. We're just going to do this, and then we're going to write another for loop j less than j plus plus as well. Now we're actually just going to be checking the value of the of each of these characters, right? And deciding whether we want to save it or whether we don't want to save it, right? That's basically what we're doing. Now let's just call this let's call it character value. Actually, I don't know, creating variable names is always the worst. Anyway, so let's call this character value, and this character value basically just going to be j I, because we are taking it like z, then w, then t, instead of z, then y dot, then x, right? Then, but what we need is not the letter itself. We're trying to get the value. So to do that in JavaScript, you have this character code as position 0, because technically it's just a 1. Then we're just going to be subtracting that from 97. And then we're just going to be checking if this character value is greater than or equal to, because we have cases like this where we have e, and it's considered lexicographically correct, right? So if it's greater than or equal to the character value, then that's fine, right? What we want to do at this point, we just want to replace the value of the character count to be equal to character value, and then that's it. That's actually what we want to do here. But otherwise, if it's not, as if it's less, what do we want to do? We want to increase the value of deleted count, because we know that this means that we're going to delete deleted column rather, sorry, because we know this means that we're going to actually delete this particular column. Not sure why this is not highlighted. Let's just copy and paste just this. Okay, and then we're going to try to jump out of this particular loop. So to do that, I just have to increase the the value of j, and I'm going to just set it as the string of length, so it jumps out of the loop. Then every time we jump out of this loop, we actually want to reset the value of the character count to 0, so it starts all over again every single time. So this is the first time it goes through this side of the bargain, then it goes through BAH, then it goes through AFI, and every single time it resets the character count to 0. And I think that that's it. Let's actually run this and see. Uh, okay, I've missed something. If character value is greater than or equal to, oh, I'm so sorry, I didn't even realize that I wasn't checking character counts. Then we just have to run this again, and yeah, now when we submit, we should be fine. And that's true, we're good. So that's how we solve that problem. I don't know if there are ways that we could optimize this. I can look. But yeah, I'll see you in the next one. Please don't forget to like and subscribe. Bye.